Okay. Today we look at an exercise called Rotate for Max from Codewars.com. And yeah, it is a Python exercise. We are ready to go this morning or something. It's almost afternoon. Okay, let's begin with an example. Take a number 5, 6, 7, 8, 9. You'll rotate left and you get 6, 7, 8, 9, 5. What is happening here, this is a common thing in programming, computer science, whatever you want to call it, where you have a set of something, whether it be a number, list, whatever, and rotation is shifting the data, where here rotating left is shifting every number to the left one spot, and the number that's all the way on the left gets shifted to the other side, really to the right. So you see the 5 ends up going to the right, and then the 6 becomes the first number. You see 6, 7, 8, 9, they shift to the left. 5 goes from the beginning to the end. That's kind of your classic rotate left scenario, where everything moves to the left by one spot, and the thing on the that is all the way on the left, when it moves over one spot, it wraps around to the right side. So that's a rotate left. So that's the beginning of this thing. And as you get further into it, keep the first digit in place and rotate left the other digits. So this is going to be a rotation with a twist, where once we rotate, we're going to keep a progressively larger number of digits fixed on the left side. And you see here it says keep the first digit in place. This is where it begins, where we shifted left to begin. We shifted everything to the left. And then on the next turn, we're going to shift everything except the leftmost digit. Then we will shift everything except the 2 leftmost digits. Then everything except the 3 leftmost digits. So we have a progressively larger number of numbers from the left becoming fixed as we rotate. So getting back in here, keeping the first digit in place, rotate left the other digits. Interesting English. So we keep the 6 in place. We rotate the other 4 to the left. These began as 7, 8, 9, 5. When you do the rotation to the left, you get 8, 9, 5, 7. Because the last 3 move to the left and the 7 wraps around to the right. So as you see, 8, 9, 5, 7. So on that turn, the 6 stayed in place, so we got a 6 in the beginning. On this next turn, it says keep the first 2 digits in place and rotate the other ones. Now on the next turn, we keep the first 2 in place and we rotate the last 3. And this is going to become 5, 7, 9. So then it'll be 6, 8, 5, 7, 9, as you see there. And then after this, you're going to keep the first 3 in place and shift the last 2. Guess this is going to become 9, 7. And so you go through as many rotations as you can, really. And let me clear this out. Moving down a little bit. Keep the first 3 digits in place, rotate the left the rest. Now it's over, since keeping the first 4 remains only 1 digit, which is rotated is itself. Well, whatever this says. But really, you rotate until there's no more digits to fix. So yeah, you keep fixing a progressively larger number of digits from the left. And really, the result is a set of rotated, a set of rotations. This one is the original. The one on the left is the original. Then this is rotation 1, 2, 3, 4. And if you really pay attention here, the number of rotations that are possible is going to be equal to the number of digits in the original number. There's 5 digits in the original number, and you see here there are 5 rotations. 0, 1, 2, 3, 4 equaling 5. So the length of the number in terms of digits will be the number of rotations. So you can kind of take that to the bank, and you can use that as a condition for a loop where I'm going to keep making rotations as long as I have not hit the length of the number digits wise. So after all that, what you actually have to do in this exercise is get the maximum of the rotations. So the maximum value out of the rotations. So here you have a set of rotations. What is the maximum out of these 5 rotations? And it tells you that the maximum is 68957. So this is just a quantity maximum. Which one of these rotations is the largest? So what we got to do here is take in a number, get all the possible rotations using this algorithm, this format. Then from those possible rotations, which one is the largest? Yeah. And on Codewars, this is a 7 Caillou. I think it's a little bit harder than a 7 because there's some complexity here. So maybe miscategorized, but it is what it is, homie. All right, let's now go into code, and I'm going to show you the code that I used to solve this problem. And no, there ain't going to be no jump cut. I am simply dragging it over, not getting fancy here. I'll leave that for my later videos. Okay. So in this function, n is going to be the multi-digit number that I'm going to take in. And I think as I explain this, I will have a multi-digit number by my side to kind of walk through the joint. And the multi-digit number I will use is 1, 2, 3, 4, 5. Very simple. So yeah, let's say n equals 1, 2, 3, 4, 5. All right, so as we come in here, I'm going to convert it to a string because doing the rotations on a string, it's just going to be easier. Yeah, you could totally do this numerically, but I didn't feel like putting in the effort to do that. So I'm going to convert to a string where I can manipulate the numbers as characters easier. So I convert it to a string, and then I set a variable I to 0 because I'm going to do looping. And here I set a variable suffix to the length of my number, really. And I'm going to be using that in the rotation process in a couple of places because having the length is useful in doing the rotation, I guess you could say formula. So that's what I'm going to use it for. On line 6, you have rot list, which this is going to be the set of all the rotations that I create. Once I do a rotation, I'm going to append it to this list, and then I'm going to get the maximum of the list at the end of my function. I start my while loop, and in this while loop, I'm going to produce all of my rotations. And I'm going to produce one rotation per iteration of the loop. So as I keep going, one rotation per iteration. And it'll loop while it's less than the length minus 1 of the string, or I guess you could say the number. And so line 8 is where a lot of the things happen, where line 8 really does the rotation, where I make my new string equal to this rotation formula. And I'll break it down a little bit using my test data that I have written up here. So we went over what rotation was. So let's see how this works in action. Let's go through iteration number 1, and maybe we'll do a couple of iterations. So the string with a slice ending at I initially, of course, is going to be 0. So this would be on the first iteration going from 0, or really the beginning, to 0, and really it will be nothing. So on first iteration, this quantity will produce nothing. And so then I'm left with the rest of it. And yeah, this is a concatenation where I'm going to do the rotation through certain syntax along with concatenation. So, okay, that's going to be nothing on the first one. So then what is this? Looking in the brackets, we have negative suffix minus 1. Suffix is the length of the string, which is going to be 5. Let's say s equals 5, the length. And 5 minus 1 is 4. So suffix minus 1 is 4. And then we have a negative on it. So it's really going to be brackets negative 4 next to the string. So negative 4 is going to be, of course, negative index. So let's see what that is. Negative 1, negative 2, negative 3, negative 4. It's going to be this 2. And so I have a slice starting at the 2 and going for the rest, which is going to be this quantity, 2, 3, 4, 5. So that's what this is. It's 2, 3, 4, 5. And then we concatenate with what? Negative suffix. Suffix is 5, as we see here. So negative suffix is negative 5. So index negative 5. Index negative 5, it's the 1. So this would be plus 1. So my result after the first rotation is 2, 3, 4, 5, 1. And there we go. There's your first rotation. Let's do one more iteration of this. Do a little bit of clearing here. And actually I haven't completed this iteration, because if we go down here on line 9, I append it to the rotation list, because I did my rotation, now I'm going to append it. Then I subtract 1 from suffix, and this is done to, well, it's going to aid in the rotation. So subtracting 1 from suffix becomes 4. I goes up by 1 because I'm going to be iterating forward, and then I loop back around. Okay, so looping back around, now my string is 2, 3, 4, 5, 1. So let's clear this out and put 2, 3, 4, 5, 1 up there. 2, 3, 4, 5, 1. There's my new string. And this is what I'm going to start with for this next iteration. Okay, let's look at this. Line 8, strnum, and then this slice I. Here, I is now 1 on this next iteration. So this would be 0 to 1. And so that would give me index 0 of my incoming string. So index 0 is the 2. So that's going to be the beginning. And it's 0 to 1, which will be the 2. So that'll be my beginning. 2 plus something. It'll be whatever this is. So that's kind of step 1. And remember that we have a progressively larger number from the left remaining fixed, and that's what this 2 is. 2 is going to remain fixed from the last rotation. See, the last rotation is this, and 2 is there. It's going to remain fixed in this next one. And as we move forward, we're going to have a larger number remaining fixed. Okay, 2 plus. And then here with string num, it is negative suffix minus 1. Suffix is now 4. It was 5, but now it's 4 due to this minusing. So it's 4. 4 minus 1, 3. So negative 3 to begin. So we're looking at index negative 3 colon to the end. It is going from index negative 3 to the end. Looking up here, negative 3 to the end is this, 4, 5, 1. So let's go 4, 5, 1. That's the next piece of our rotation. Then we're going to do a plus for this, and look at the rest. Okay, negative suffix. Negative suffix is 4, negative 4, and this is simply an index. This is not a slice. Negative 4 is going to be the 3, which is going to be at the end. So after this iteration, we have 2, 4, 5, 1, 3. That is the next rotation. You take that rotation, append it, and then suffix changes now to 3, and then I will change to 2. So those are the first 2 iterations. And because of the depth of these and how long it takes to explain them, I'm going to stop here. But you continue on this path, get all the iterations, get all the rotations, and they're going to be put into the rotation list. And what I'm going to do now is I'm going to run this code with 1, 2, 3, 4, 5 as the input, and you're going to see that the first 2 rotations are in fact 2, 3, 4, 5, 1 and 2, 4, 5, 1, 3. Here are your first 2 rotations as I explained. Because on line 12 I'm printing them out, and you're going to see those first 2 rotations along with the rest of them. I'll go ahead and run it. There we go. And yeah, I didn't explain this, but in the code, I put the first rotation. I kind of preloaded with the first rotation on line 6. Because the first rotation is the original number that is the argument. So that one goes into the list first. Then the next rotation is the actual first rotation that we do with this algorithm. Okay, so first rotation is 2, 3, 4, 5, 1. As you see up there, and there it is, 2, 3, 4, 5, 1. The next one is 2, 4, 5, 1, 3, which is right here. So there's proof positive of the operation of the algorithm. And if you don't get the algorithm, go back and run through it again, and then try to analyze it a little bit. But pretty interesting stuff with this one. Yeah, there's some depth here. All right, so there's the set of rotations, and I'm going to clear this out and now run the test cases, or a couple of them, from Codewars, and make sure things are correct. I'm going to comment this out, and let's look at Codewars, and let's see, get in here, dip in, and looking at test cases down here. Let's see this, yeah. This test case results in this output. So let us go side by side here a little bit. I don't know what the hell that was. It's kind of messed up. Okay, yeah, we see a test case. Okay, that should result in 858 blah blah blah. Let's throw it in there. 858 blah blah blah. Same. Good. Let's do another one. That should result in 988 blah blah blah. Blah 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 blah. And it does. Test cases look good. Outcomes look good. So let me drop this in to the Codewars training area. Let's patch this up and keep it moving. All right, run the test. That's good. Run another test. That's good. Let's go. Time to flex. Impressive. And that is it with this one. This is Rotate for a Max. And I'll show you the code again real quick. There's your code for Rotate for a Max from Codewars. Python exercise. Keep coding, keep grinding, keep flexing. I am out.